Hey, fifth graders. All right, so this is going to be 11.4, which is three-dimensional figures. So we've moved on from polygons. Now we're going to talk about polyhedrons and non-polyhedrons. So let's first of all look at the definitions of these words. So when we have a polyhedron, really we're talking about well, for our purposes, we're talking about a prism or a square or a pyramid, which we'll get to here in just a second. But a polyhedron is a three-dimensional figure that's got lateral, or it's got faces, and it's got that are made up of polygons. Okay, so let's say 3D figure with faces. Don't think of faces like your smiling face, but like outside parts made of polygons. Okay. So this could be something like a prism or a pyramid, which we'll talk about here. If probably the easiest one to think of is like a box, which I'm going to draw a not very good picture of here. There we go, not too bad. Okay, right? So here you'll notice that all of the faces are squares, right? Like that's a square there, that's a square there, assuming that they're actually good, well done. There's a square on top. If we put the little dots in here to show what's behind it, you'd see there's a square in the back. There's a couple squares in the back. It's got six squares that are all put together to make a box. Okay, so a prism, kind of very similar. It's a polyhedron. With two bases, and the two bases are congruent polygons. That's kind of the important thing. Let's see, made of congruent, which means the same. And then it's got lateral faces that are connecting them. In the case of a prism, the lateral faces are going to, generally speaking, be rectangles. So if I was to, let's say, well, we'll do a triangle, right? So I've got a triangle here, and then I've got a triangle down here, right? And if I connect them, this now becomes kind of in the background, so you can't really see it. So let's just make these little dots. Okay, we'll pretend like it's made out of glass, so you can kind of see the edge through there. All right, this is a rectangle, or would be if we were setting it up straight. Okay, and in the back here, we'd also have a rectangle, and then on the bottom we have another rectangle, right? But the two bases, even though when we think of base, we tend to think of it being like on the bottom or the top, but if you tip it sideways, the base stays the same. Right, so if I have this, this is going to get me in trouble, looking something like that, right? And then I tip it over. Well, this here, this is the base, but then now it's just right there. Okay, all I did was I tipped it over. So it doesn't change just because you change the angle that you're looking at. It doesn't change where the base is. And usually, with the exception, of course, of this shape here, assuming that all those sides are the same, usually it's easy to tell what the base is because the base is the one that is only has one other side that's the same. The one exception, of course, is when you have a cube like this, all of the bases and all the lateral faces are exactly the same because they're all just squares that are the same size. Okay, so that is a prism. A pyramid is a polyhedron with one base whose lateral sides meet at a point. Okay, so you guys all know what pyramids are. When you think of like the pyramids in Egypt and things like that. Same idea, right? So a pyramid is that sort of shape, right? Okay, so here we have our base down here, which is just a triangle. And they all meet at a point. Now, you don't have to just have a triangle down here. We could have had, let's make some sort of crazy shape. Something like that. Oh, that's just awful. Let's go that way, that way, that way. Okay, well, these sides over here are going to be kind of messy. Let's just make it one side. There, okay. So down here, we have 1, this is 2, 3, 4, 5, 6, 7, I think. Yeah, we'll say 7. So that makes it a, oh boy, heptagon? Let me look back. Ah, heptagon, good. All right, didn't forget. So this is a heptagon, and if all of these sides, this is in the back. Ooh, actually, I need to be able to see that one. That one, and that one. All right, so all 7 of these sides here come up to a single point, then this is a heptagonal pyramid. Okay, so it doesn't have to just be a triangle or a square. It can be lots of other shapes, and we'll talk about that here in just a second. Okay, so the base is basically, how would I describe this? It is a polygon. Let's say it's a polygon from which the lateral sides of a, really it should be a 3D figure. Not sure if that's the best definition, but that's basically what it is, right? It's a polygon from which the lateral sides of a 3D figure, that says later, lateral sides of a 3D figure extend. Wow, I did some amazing spelling. Is what happens when I'm tired. Okay, lateral faces are the polygons that connect with the base. All right, so this pretty much is going to cover with prisms and pyramids, these words here. Now we have non-polyhedrons. This is the other part that your chapter is going to talk about. This is on page 656. So non-polyhedrons, kind of a funny way of putting it, because if something is a non this other thing, then that means that it's just not that, right? So everything that is not a polyhedron is a non-polyhedron. So a line or a polygon kind of fall into non-polyhedrons, at least if you want to get technical on what the words mean. However, in this case, when we're talking about non-polyhedrons, we are talking about three-dimensional surfaces or three-dimensional figures that have curved or rounded surfaces. So if you look at like a ball, right? A ball is a 3D figure, but it is not considered to be a polyhedron because its sides and its faces aren't made up of polygons. They are, well, they're not anything. It's just a curve, right? It's curved. Same thing with a cylinder. So if you think of cylinders like a soda can, right? So you got 2 circles on the top. Circles, because they don't have sides. They have sides, but they don't have any angles. So circles are not considered to be polygons, and consequently, when you basically just take a rectangle and wrap it around a circle to connect these 2 circles, that does not make it into a polyhedron. And then, of course, you have a cone, which is very similar to a pyramid, except for its base is a circle. and so there's no sides really, at least not the way we define sides, but it just kind of has a curved surface that goes up to a single point. Okay, so that's all of the stuff here. So this is going to be an easy lesson for you now that you've listened to my spiel here for the last 10 minutes. Basically, all you have to do is classify all of these different shapes. Okay, so the one thing that we didn't really talk about here is if you have, sorry, I just realized that there is a thing that we're missing here. So let's see. Oh no, just kidding, I was wrong. I guess the only thing we'd have to talk about is our shape names. So in particular, when it comes to prisms and pyramids, all right, we kind of talked about this a little bit. So let's do something like that, all right? So here we have a box. It is a, this would be considered a prism, right? It's a rectangular prism. Because if you look, and in this case, when it comes to these, it doesn't always necessarily matter. When you're dealing with rectangles and squares, it doesn't always matter what you choose to use as your base because the sides aren't going to all be the same length anyway. So here, like this could be our base, but we could just as easily have said this was the base, or the bottom is the base, or the top is the base. Doesn't really matter. Okay, but in this case, because all of the bases are rectangles, this is a rectangular and then because we don't come up to a point, right, we just go to, regardless of which base you use, the opposite side is a congruent polygon to it. So in this case, all congruent rectangles, theoretically, this side here is the same as this back side here. This side here is the same as back here. Top same as bottom, etc. So this is a prism. It's not a pyramid. So this is a rectangular prism. Okay, and I already kind of showed you an example with pyramids. Maybe I should have used a here. Let's do. Well, I guess it doesn't really matter. Yeah, so we already talked about pyramids there, but if you have, let's say, oh, actually, this is probably a good one to show you. These are all examples that are coming out of the book, so I'm basically just giving you answers, but that's okay. Okay, so again, dashed lines are, it's glass and you're looking and seeing the back. Okay, now, here's a little bit different, right? So here, we have a rectangle here. We also have a rectangle on this side and then a rectangle over here. Okay, so we've got three rectangles extending up from triangular bases. So here's your base, and that means that this is also the base. Okay, and in this case, the base is a triangle. So because we have two bases, that means that it is a prism, not to be confused with prison, and it is a triangular prism. Okay. So we've got two bases. They happen to be triangles, so it's triangular, and then because we have two bases, it's a prism. If we had well, no, let's do it this way. Okay, so now here we have a triangle as our base. The base happens to be on top. When you're dealing with this particular shape, which is a pyramid, you can always tell the base because it's the opposite of where everything else meets. Okay, so we have a base down here, or we have a point here. We've got a base up here. So this is a pyramid. And again, because then we just look at the base. The base is a triangle. So we have a triangular pyramid. Okay, makes sense? Easy, right? Okay, so on the lesson, looks like that's the That's pretty much everything. It's just gonna be a matter of naming it. If you're confused about some of the names, so when you get to like, obviously you guys know rectangular, you know, yeah, you know most of your shapes. Triangle, rectangle are the big ones. But if you're not sure what the shape is, just count the number of sides and then look back to lesson 1, and you'll see how many sides there are there. So anyway, that's it for this lesson. Good luck. That's lesson 4, and then after that is going to be the mid-chapter checkpoint. So that should get you through at least the next several pages. Anyway, good luck, and I'll talk to you later. Bye.